Good afternoon, everybody. I'm Jason Gibson, CCO at IACMI. Innovation Insights is our monthly webinar series highlighting the people, ideas, and partnerships driving advances in composites and manufacturing across the U.S. As part of the Manufacturing USA Network, IACMI leads national efforts to scale new materials, develop sustainable processes, and strengthen U.S. manufacturing competitiveness. Now, before we get started, I'd just like to mention that if you have any questions during our presentation, please enter them into the Q&A section down below, and we'll ask them to our presenters at the end of each section. At IACMI, our mission is to convene, connect, and catalyze. We convene the composites community to share ideas and opportunities, connect industry, academia, and national labs, and catalyze real progress through collaboration and commercialization. And today's Innovation Insights reflects that mission, highlighting new ideas, technologies, and applications driving the future of composites. For those new to IACMI, we accelerate composite innovation to strengthen U.S. manufacturing and workforce competitiveness through co-funded projects, access to world-class facilities, and a powerful national network. Now, if you're listening today and you're not currently an IACMI member, we encourage you to consider the value of joining. When you become an IACMI member, you gain more than just affiliation. You join a national network accelerating innovation in composites. IACMI gives you a platform to engage, contribute, and make an impact. We'd be excited to welcome you into our community, so please visit our website and reach out to us by filling out the online form. And if this is your first time attending, we encourage you to explore past episodes that are available on our website. Since its launch, Innovation Insights has convened members and partners from across the composites ecosystem to share practical applications, emerging technologies, and lessons learned from active R&D and commercialization efforts. This series is designed to keep you current on industry trends while creating direct access to the people and ideas shaping the next generation of composite materials and manufacturing technologies. And today is a good example of that. So let me introduce our speakers. Today's Innovation Insights features 3 presentations that showcase how innovation is advancing the composites industry, from large format digital manufacturing and high-rate thermoplastic processing to an innovative transportation concept that highlights the transformative potential of advanced composites. Collectively, today's speakers will demonstrate how advances in materials, manufacturing technologies, and engineering are creating new opportunities to improve performance, increase manufacturing efficiency, and expand the use of composites across a broad range of commercial and infrastructure applications. So we'll begin today with Chris Sentz, CEO of Vitruvian, who'll showcase how large format composite fabrication is being applied to real-world commercial projects, ranging from festival stages to durable infrastructure signage. Chris will also highlight Vitruvian's workforce development approach, where technicians gain hands-on experience through live production while developing digital fabrication skills that support the future of advanced manufacturing. Next, Peter Levesque, Design and Project Engineering Manager at TXV, will discuss how Victrex's LMPAEK thermoplastic materials are enabling high-rate manufacturing of composite parts and assemblies. Peter will explore the processing tools, the material formats, and design strategies that are helping manufacturers improve production efficiency while expanding the use of high-performance thermoplastic composites. And then finally, we'll conclude with Gene Temperman, President and Executive Engineer at AirTrack. Personally, I find AirTrack's concept to be one of the more innovative transportation ideas I've seen in recent years. Eugene will introduce AirTrack's vision for transforming regional transportation through an innovative, elevated transit system built around advanced composite structures. His presentation will explore how lightweight composite guideways, modular infrastructure, and air cushion technology can reduce construction costs, improve system efficiency, and create new opportunities for sustainable passenger and freight transportation. So with that, I'd like to go ahead and turn it over to Chris Sentz. Chris, I'm going to stop sharing and feel free to start your presentation.
Sounds great. I appreciate that, Jason. Thanks for having us in here today. We're new members to IACMI and really enjoyed the membership thus far. Got to experience the Denver event and meet a lot of great people out there. Like Jason said, today we'll be talking about some of the practical applications that we've seen with our composites, and really importantly, what we're doing to engage the current workforce, the modern workforce, and bring them in to the industry using this novel technology. Um, the thing that we've seen both in manufacturing and in construction is there's a lot of projected unfilled jobs. That we currently have a lot of unfilled jobs, and that number is going to get worse and worse over time. Vitruvian exists to solve the housing crisis, and that was the first obstacle that we came across, is that labor is one of the major issues. Technology is an issue, but technology is really there to address labor at the end of the day. What we found is that we can use technology to attract new types of labor to the labor pool, and do so in a really engaging way. Ours starts with technology. I think like any tech company, we get excited about our machines. We have two large format printing systems. One's composite, one is cementitious. Today we're talking composite, so we're talking about the Mantis. This is built on a KUKA robotic system, large format. We can do anything from architectural components down to automotive components. And there's a lot of stuff that can be done with these flexible systems. And that's what makes them exciting, is we can set them up to run for weeks, creating one thing, or every few hours change what that output looks like. And it's built for the real world. We're putting out things that are not bleeding edge. These are materials and products that are being used today. You're going to see examples in this presentation. We're excited about some of these things, but everything from the large format where we're doing 100+ foot installations to custom, smaller parts. But again, with a system like this, automotive is probably about the smallest, and maybe furniture is about the smallest thing that we're printing. So if I ran into you in Denver, I was probably showing you pictures and video from this. This was our latest large installation. We did this year for something called the Forbidden Kingdom Festival. This was 3 weeks of printing. It was quite a sprint to put in an 86-foot tall Gothic castle that rose above the main stage. So if you're on the ground, this thing's 100 feet above you. And you can see in these pictures just what we did. We're printing the columns and the parts of this. They were then painted on site, had to go through extensive testing. And the pictures at the bottom are professional photography. That's not AI. That's actually this thing being used, flames being shot up the side of it. It was one of the coolest projects we've taken a part of. And it did well. It was performant in that didn't light fire, which is great, of course. It got a lot of lift on social media for this festival. They were able to sell out their 2027 tickets within 4 hours of releasing them based on the experience of this event. So to them, that's quite an economic success. Much more grounded, we've built using molds, signage. And you can build signage, very traditionally, obviously, as well. But one of the unique things that we found with our composite systems is you can do some really amazing work and then infill it. So we like to work across different aggregates, different modes, and using cementitious aggregate. And this was actually coal-based, which we'll talk about a little bit here. You're able to make something that's really durable and still get all the flexibility of 3D printing. So we made these beautiful molds where they feel like they're flowing with the land for this partner of ours across their large campus. And they have about 18 counties in Ohio that they serve. So this is a very large trail system, a very large purview for their business. And when we got into that, we actually started dealing with coal. Coal both for our printed aggregate as well as that infill. Coal is an example, but one of the things that I urge us just as composites as an industry is really push what we can do with aggregate. There's some really interesting areas in the aggregate life cycles and understanding what can be used. that can have impacts. And regardless of what the situation is and where the incentives are to use different aggregates, I think it's up to us as an industry to really push the envelope, and it makes us be more relevant. The more things that we can use while we're building and the different uses. We find that coal can actually add, it's not just a filler. It can enhance the strength. It can lighten our products that we're using. It can actually give it a new and unique aesthetic. So beyond just, hey, we're using coal for coal's sake, or we're just trying to get something out of, the waste stream, there are really positive upsides to using coal aggregate specifically. And I think we can find those in a lot of different industrial aggregates out there that might be being overlooked. So we get really excited about that. Now, I think at the core of our message and what we do is workforce engagement. Like I said at the beginning, we're running into an issue with this country. We're onshoring a lot of manufacturing. We want to be more active in the built environment, whether we're building houses, commercial structures, or just manufacturing items in the United States for a lot of reasons. But to be competitive, we have to be. And we're finding that there's a gap because the modern workforce has not really been set up to take these jobs, even though they're really strong quality jobs. So we use these really neat, novel projects that we get access to, and we bring them to communities. And then we actually train both K through 12 and post-secondary folks, so people in the educational pathway already. We do transitional and we do incumbent workforce. So folks who have jobs that want to learn new skills and increase their wage rate. Those areas are all impacted really positively with what we're doing. We essentially use it as a labor attractant, big, neat machines with huge output and overwhelming projects. And we found that with the right type of education on top of that, we can build in industry recognized credentials and stack them in such a way that as you're learning about 3D printing, you're learning things like CAD, you're learning all these robotics and workplace safety and manufacturing that are then very translatable. We've trained a lot more people than we can hire in less than 12 months of accredited training. We do have accredited training through the state of Ohio. We've trained over 150 participants, 100% completion rate. That means anyone who starts is actually completing it, which is almost unheard of. And on top of that, our placement rate is 99+%. So if you're taking this training, you're getting a job if you want a job, or you're continuing your educational path in a STEM focus. We're really, really excited about that. And some key partners have been the United Steelworkers. They turned us on to manufacturing and said, we need more folks in manufacturing. We've worked with the International Masonry Institute and the bricklayers as well on the cementitious side. And we have some wonderful workforce partners. So we're interested in continuing to do that and continuing to help manufacturers as they're looking to expand, find more of a workforce. We're really good at that piece of it. And this is learn, credential, produce, and earn, right? So very straightforward pathway, getting into prototyping, getting into CAD and robotics in this large format. And we find that folks for a long time were told manufacturing isn't a place to get into for a career, that construction wasn't a place for a career. We have this mentality today that has been set up for a long time, almost a century, to say, hey, let's get away from those things. Let's go to a different job market. And what that's left us with is a really ripe job market in manufacturing construction spaces with meaningful wages. And we're starting in manufacturing $20 an hour, working up to 45 in a couple of years. And that's a really strong wage rate for a 17, 18, 19-year-old all the way through, and they'll continue earning through their lifetime. And the manufacturing, as we all know, is a much safer environment than it used to be. This is a worker forward environment, and we can teach and open up new pathways for folks using these really neat projects and technologies that we have built over time. So lessons that we've learned along the way, outdoor with composites is super interesting. We really encourage testing. Finishing is important, coating and making sure that there's weatherproofing is great. Designing to real world environment is a unique thing to do. We have a great engineering team. I will tell you that when you just put something on paper and when you test it in the real world environment, we all know that's very different things. And when we're talking about festivals with hundreds of thousands of people experiencing something in a short amount of time, or extreme weather events, it's really important to test early and often. It's also really neat that you can do things beyond just straight building. You can mold, you can cast, and you can do so quickly and prototype very quickly. And the speed with which we can deliver using these materials and technology is wild. To get a job and within 3 weeks deliver tons, literally thousands and thousands and tens of thousands of pounds of finished goods with 24/7 printing is, I mean, this is a new thing. This used to have taken months just to get the parts correctly entered in a manufacturing system to put them out. So when we talk about 3D printing and additive manufacturing, you bring a flexibility that's really been unheard of to this point. And I think the workforce, the economics that drive this, we can do one-off prints and one-off projects, and we're really proud of that. So if you have a unique project that you need that is large format, we want to be speaking with you. We like making things near the install and engaging a local workforce. So wherever we do things, we actually don't want Vitruvian to be the ones delivering it. We want a local engaged workforce to do that. And we do that all the way from our factory itself, which is in Athens. And we'll have more factories in other communities by the end of this year, like we have 3 distributed factories. But even when that print's delivered and installed, we want to educate a local workforce on how to do that. So when we work on these trail systems, we're working with a community technical center and actually educating their workforce and the kids there on how to do these installations. So this community can fend for itself. That's at the end of the day what we want to do. And we're looking for folks that we can work with. So, I'd say that the landing message is let's build together. We're really excited. We're happy to be part of IACMI, and we're looking forward to connecting with folks, whether it's workforce programs and developing accredited learners who can get involved in the modern workforce or doing build projects. We can build it of all sizes. We're excited. Thank you.
Chris, that's really good stuff. Got a couple questions for you. It sounds like you have an incredible uh, placement rate for people that you're training up in these different capabilities. What types of jobs are they landing when they come out and get into the workforce?
We were all over the place. Our first programs were all construction focused. So we sent people to the construction unions, we sent people to contractors, and then things like city jobs and things like that. As we get into manufacturing, we have partnerships with some of these more big mega projects in Ohio. So they're getting into more traditional manufacturing roles. And outside of that, we've had a lot of folks who continue the STEM pathway. So high school students who now can put on their college applications that they've built a house with a 3D printer or they've done these large format things and going to engineering schools, which we're proud of, like Purdue and the University of Cincinnati and some really great programs.
Hey, got another question that came up. Hold on, I got to pull it up here. What polymer reinforcement system was used on the stage construction?
Phew. I have my engineers on the call, so you can shoot me an email. But what we did essentially on the stage was it was a facade over the metal stage framing. I don't have the details because my team is the smart guys behind it. I'm just the beautiful face. But if you are interested in knowing more details, shoot me an email. We can do a meeting with my engineering team. But essentially, you picture the stage scaffolding traditionally, those metal pieces. Ours were built to go around those pieces and then be tied into those. So they are not structural pieces. They are just for looks.
Okay. And then the last question for you, are you doing or considering doing this in other states? It says, I love the partnership with workforce development slash schools. So are you considering expanding into other states?
Absolutely. Very interested in other states. We have 10 that we're working on right now outside of Ohio. We are an Ohio-based company, but we would be interested. So again, shoot me an email. We're interested in getting this into every state because it is so impactful in these local communities.
Great. Well, appreciate the presentation. In the interest of time, we're going to go ahead and switch now to Peter Levesque. Peter, if you wouldn't mind sharing your screen and jumping into your presentation.
Sure thing. Thank you, Jason. Okay. I believe you can see the title page here.
Yep, looks good.
Good. Okay. I'll be talking about high rate thermoplastic composite part manufacturing. I work for a company, TXV Aero Composites, and we are a Victrex owned company. If I can figure out how to advance. There we go. Victrex itself invented the polymer PEEK, PEEK. Victrex is the world leading manufacturer of PEEK, has by far the most time manufacturing it and the most global capacity. And Victrex itself is vertically integrated in that we own back to the monomer and up forward into forms and into the parts. We're organized in by market, and I work in the aerospace manufacturing side of things. PEEK is a pretty amazing polymer. It does all of these things around the circle well. We like to say that you need 2 or 3 or 4 of these in order to make PEEK make sense, because PEEK is an expensive polymer to manufacture. But if you have an application that needs mechanical strength, it needs to be bioinert or chemically resistant, and easily processable, then the list of materials that tick all of those boxes starts to get pretty short. So if you only need one of these things like bioinert, then there's other materials that will do that job. If you only need wear properties, there's something else that's cheaper and easier to work with that will do the job. But we are at the top of the polymer pyramid on the semi-crystalline side, and that gives us all of these fantastic material properties that we'll deploy in a bunch of different applications. As I mentioned at the beginning, Victrex makes the polymer, but we also make many forms of the polymer. After PEEK, the patent on PEEK ran out, Victrex created a more easily processable polymer called low melt, PAEK, low melt PAEK. It's our trade name is AE250, but it's pretty widely known in the composites industry as low melt PAEK. That polymer, that powder, can be turned into a number of different forms. One being filament, a fiber in and of itself. Another is films, and another is compounding with glass or carbon fibers. Those are all useful for making parts in their own forms or as additives to other parts. But we here at TXV, we primarily use the UD tape. So you can make a pre-preg tape, or others use it to make a pre-preg woven product. And then we manufacture composite parts out of that UD tape. So continuous carbon fiber with a low melt PAEK matrix. We combine that UD tape with injection molding compound pellets for hybrid parts, which I'll talk about in a little bit. And we also combine it with film, when maybe a insulative surface is required, or we want a resin-rich surface for welding. All of these materials, when they're deployed in aerospace, they require allowables. And as these materials are relatively new and don't have decades of history out in the market and being used, we took it upon ourselves to generate allowables for the UD tape. So we worked with NIAR and created the basis of the pyramid here through all the coupon testing to generate lamina and laminate level allowables. We've done that for our UD tape with a AS4 fiber from Hexcel, as well as an AS7 fiber from Hexcel. And then Toray has also done this with their T700 fiber UD tape and their T300 5-harness satin woven product. Now these coupons establish the base of the pyramid, the fundamental building block that engineers and designers will use in order to start their design. So it's the library or the bookshelved material properties that they will need in order to begin designing their elements, which turn into details and components and then the system. We've also done quite a bit of work establishing properties of the injection molding compounds, the films, and the fibers. The polymer itself is very well documented and very well understood, and that is from two angles. One, the performance of it, like you saw with the allowables, but also the manufacturing and processing of it. It's important, we find, to absolutely be able to predict how a part will turn out, either through mold flow and injection molding simulation software, or through stamp forming and draping software. And that covers the flow, the fiber alignment, the crystallization rates, everything that you might want to then overlay onto a finite element analysis and finite element study and predict performance. So the beauty of combining PEEK and low melt PAEK is its ability to make hybrid parts. We make our composite pieces out of the low melt PAEK, and that melts at a temperature of 304 degrees Celsius. When we combine it with PEEK, we injection mold PEEK onto that laminate surface at 340 degrees C. The difference, the 40 degree, 36 degree difference in melt temperature remelts the surface of the laminate, and when they freeze, the two polymers freeze off together and they create a welded connection. So you can have this this part that has the strength and stiffness of a continuous fiber unidirectional carbon structure, but also the functionality of an injection molded component. So we here at TXV, we are solving a problem that Victrex identified in the marketplace. With this low melt PAEK polymer and collection of unidirectional tapes and composites, there was a number of parts that could be manufactured either as straight composite components or as hybrids. But Victrex saw that they were playing matchmaker, and they were finding somebody to do the design work, somebody else to do some analysis and modeling of it, whether it's structural or manufacturing analysis, and then maybe find a tool maker, and then somebody who could do the prototyping and testing, and then somebody who could eventually transition to serial production. 9 years ago, Victrex created TXV, and we are all of those things under one roof. So we take parts from that concept design early on, all the way through to serial production at the end. So we've developed this process expertise, and we've got the decades of material expertise from Victrex, and we've combined that with a collaborative engineering approach where we're really trying to understand the application and educate the customer a little bit on what the possible solutions could be with this polymer system, so that we can design and build parts that will be manufactured at rate and save money and save weight. So while we bring the materials and the process expertise to the equation, we don't know anything about the application. So we have to really lean on the customer to understand exactly what their part is doing. What problem does it solve? What is its original use and intent? We go through a number of questions to try to peel back the layers of this part and try to figure out exactly why it is the way it is, so that we can rebuild it in a parallel solution using these materials and this process. It's not always linear. We end up going over certain requirements a couple of times until we get it right, because our initial understanding of the part is, on the surface only, and we'll try to come up with a solution that can be made, something that we could potentially wrap a tool around, try to see if it hits the cost and performance targets, and then inevitably, when we present that to the customer, we'll get some additional feedback, and then we'll have to home in through a couple of iterations of this path down to the final design, where we're all confident that we can cut a tool and cut some steel and then eventually make some parts. What happens though along the way is there's a number of these design enablers that exist because of the polymer and the material combinations. When we're combining the two polymers, they're close cousins to each other, so the weld connection is very good. We're combining short fibers with continuous fibers. We're combining stamp forming with injection molding, and we're potentially welding parts together as well. So there's quite a bit of opportunity to come up with the ideal part and save weight and really have a very elegant thermoplastic composite solution. But it takes a little while, and there's a whole tool set that we use to de-risk the question of cutting tools around those. Our manufacturing environment here, we're located in Bristol, Rhode Island, and we have a highly automated manufacturing environment. We have just as many engineers as we do operators, and our engineers are working with the robots and the automated systems and building out the factory so that each of these cells is really single operator run, and we can build parts at high rate. It's very scalable. Each part we're measuring the touch time in minutes or seconds, and in many cases we're building parts in multiple parts per cycle. So it's a very efficient manufacturing process, really enabled by these high performance polymers. We have a bit of a screening process that we like to use to figure out what's the right part. Certainly complex parts and parts that allow themselves to be combined and reduce part count is good. Part complexity is typically not something that goes along with composites, but when you add in the ability to injection mold features, you can really make some beautiful and otherwise impossible composite parts using injection molding to add those features. We also like to look at the buy to fly ratio of the existing part. Many times we're looking at a hogged out aluminum or titanium chunk of metal, and those tend to spend a lot of time in the machine creating chips. So they might buy, 10 times the amount of material compared to what actually flies. Whereas we'll maybe buy 1.2 times the amount of material that actually flies. I mentioned part consolidation. When you're functionalizing a composite with injection overmolding, you have a golden opportunity to reduce part count. And then certainly mechanical performance. These are high performance materials and high performing parts. So if it's decorative or not being asked to do a difficult job, then it's probably not a good fit. And like anybody else, we like high unit volume, but we found that if you tick enough of the boxes early on, the unit volume problem actually isn't that bad. We've seen parts that make sense at single piece per ship set. A couple of examples of parts. Many of these are simply stamp formed, but these are either stamp formed shells, much like metallic stamp forming, or in a few cases we've got some hybrids. And the hybrids, we like to think of them as one of two parts, one of two types of parts. Either it's a shell that needs local functionalizing, local features that you want to injection mold, or it's primarily an injection molded part that requires local composite reinforcement. So think of it as the composite could be the bones inside the overmolded flesh and muscle. Like I said, these are high performing materials, so you can reduce a lot of weight and accomplish the same job. And because they're thermoplastic based, they really lend themselves to high rate manufacturing. So you can take a lot of cost out of these parts. Again, reducing weight, reducing cost. We understand that in many cases we have to sort of buy our way onto the airplane or onto the application, and these parts typically have no problem doing that. More cost and weight savings. This mentions the buy to fly ratio. So in this particular part, the incumbent piece was basically buying 6 times the amount of material compared to what actually made it onto the plane. So you can see that that $3 or $4 per pound piece of aluminum now is quite a bit more expensive before you've even put it in the machine. So with that, we can open it up to questions.
Peter, I got a couple questions for you. The first one is, has PEEK been used or is it being used in high temperature environments such as ablative composites for aerospace?
Ablative, I'm not so sure about. It's I guess intentionally quite high. I don't know of any myself, but I can look into it. Certainly, there's definitely people at Victrex with more history than I do, and they would know.
Question. How are the LMPAEK prepregs manufactured? In other words, are you filming them and then prepregging, or are you doing a powder fluidized bath, etc.?
I would say all of the above. It just depends on the manufacturer. We have our method, which is, I think, a pretty traditional method. And I know Torre has their method, and Tajin and Bardet and Ensinger, they all do it their own way. But it can be done in basically any of those.
Great. All right, well, in the interest of time, we're going to move on, but thank you for the presentation. And let's go ahead and switch it over to Gene. Gene, if you wouldn't mind trying to share your screen and jump into your presentation. And you'll need to unmute too, Gene, so we can hear you.
All right. Very good. I think I'm on.
You're on. You just need to throw it into presentation mode.
Okay. There.
Perfect. Looks good.
Very good. Well, thank you, Jason, for your very accurate introduction. And I encourage anyone listening to this to review that introduction because it's very, very accurate. We're going to talk today about transportation. And we have 4 modes of transportation: roadways, waterways, railways, and airways. In recent years, of course, demand has been increasing, and trying to keep up with those increases in demand has been very, very expensive for our country. And so adding more lanes to a highway, the congestion doesn't go away, and the improvement is marginal. High-speed rail, trying to add another rail system to the country. Well, we all know where that's going. Adding a new airports, a new jet runway costs $1 billion up, and it goes up from there. They all need a lot of land, which is not readily available. So I challenge people to say, what if we built a new system that would be safer, faster, cheaper, and convenient? And a new system, an entirely new system, would dramatically increase capacity. If we think about the aircraft industry, that technology is lighter, stronger, and more flexible. Also included in that technology is air cushion technology, hovercraft, which we have here. And in this machine, you have a fan in the front, you have a fan in the back. You draw air into the top of that machine through a fan, and you distribute it around the periphery of the craft and inject it or eject it underneath, raising the static pressure. And that technology affords us the opportunity to lift tons, inches off the ground with minimal horsepower. Now, thinking about that technology, and oh, come on. Let me try this again. Yes, thinking about that technology, let's think about adding a circular arc to the bottom of this flat hovercraft machine. And what we come up with is a concentrically designed air cushion machine that runs in a trough. That replaces wheels and tires, which are speed limiting. And does this concept work? Well, we ran a proof of concept model, and you can see here the uniformity of the cushion around that arc. Now, having a concentrically designed air cushion machine in a trough, which we now call a guideway, putting a roof over the top of it for all-weather operation, hang a vehicle underneath of it, and support that guideway on cross members and towers, we now have the elements required for a mass transit system. It is modular. You start with foundations in the ground, towers, cross members, and guideway pieces between the towers. It can be put up in pieces. It can also be taken down in pieces. A radical new idea for ground mass transit. Also integral with the air track concept is a high-speed switch, which is a switch rail mounted on a balance beam system that is motivated up and down by shifting weights back and forth. And it works like this. The vehicle comes along, descends one guideway diameter, and departs that switch area on the original route. The switch rail comes down. Another vehicle can pass over that switch rail and depart on the alternate route. And they do that at speed, 70, 80, 90 miles an hour. Now, the assembly here, this configuration of air cushion machine, concentrically designed, hanging a vehicle below it, forms a natural pendulum. And that brings air track a tremendous advantage in being able to make a coordinated turn, no matter what speed it's doing or what radius of curvature it has to negotiate. So in the whole system, then you see that we have guideways and we have vehicles, hangars, towers, and cross members, all made out of composites materials. And of course, this is not the start of a new business. This is the start of a new industry. And it's going to have a tremendous impact on the composites industry. Dennis Muhlenberg is our board chair. He is the former president and CEO of the Boeing Company. Greg Martin is the former vice president of engineering and technology for the Phantom Works. He spent his career there. He was Boeing's lead engineer on the design, launch, and assembly of the International Space Station, and that just starts his resume. When we briefed him, he said, well, while I was at the Phantom Works, we took pencil drawings of combat aircraft to flying prototypes in less than a year, and air track is nowhere near that complicated. He said, give me $2 billion in 36 months and I'll commercialize air track with destructive testing and government certification. Now, Zoltec Corporation has been supporting us for some 5 years or so. And of course, we all know that it's the US's largest manufacturer of carbon fiber. They brought us A&S Technology, engineering company, and they did an analysis of the system, the guideway system particularly, and verified my calculations for strength and cost. They also added the comment that 1 mile of the air track system would use more composites than the wind industry has used in a year's time. Now, air track is based on flexible structures, just like these airliners are flexible structures. Even though most people think of those wings as rigid, they are not. Our guideway on air track is likewise somewhat flexible, plus or minus 2 inches and 125 feet. As the craft goes down the way, it will generate a vibration, which is damped out by dynamic links in the hangars, so that the vehicle rides on a straight line and is very comfortable. This flexible structure concept for ground mass transit is a radical departure from our historic rigid rail systems, high-speed rail particularly, and also maglev rail, other places in the world, which use just massive infrastructures. It's also based on using existing rights-of-way, simply because it's a pendulum-hung system and it's limited to 200 miles an hour maximum speed. So it can negotiate serpentine corridors. The picture here on the left is a traffic stoppage in Wyoming on Interstate I-80 during a winter snowstorm. Superimposing air track on top of that gives you an idea of how we could obviate that kind of a stoppage. Air track can also unload our overused highways to permit them to run more according to design, and then they'll become much more safe and convenient. Air track is an additive technology, and that is demonstrated by the fact that if we were able to use railway right-of-ways, we would add regular and very frequent passenger traffic and partial freight traffic income to their bottom lines. Air track, so far I've said that they are elevated on towers. We could also elevate them on arches so that this permits us to move through dense metropolitan areas such as 42nd Street in Manhattan. Suspension bridge technology also gives us the opportunity to step across difficult infrastructures in our city cores. And even though Cincinnati is not a huge city, it does have a dense core. Elevated transportation throughout the world has demonstrated itself as being the most safe form of transit that there is. And this is demonstrated by Germany's 125-year-old Wuppertal system, which was started operation in 1901. It's moving today even 25 million passengers a year. It's had one fatal accident caused by a maintenance error, which should have never happened. So air track will be very safe. And it's also an independent system. We don't interfere with anybody, and nobody interferes with us. The value of air track is dramatically demonstrated by looking at California high-speed rail from Merced to Bakersfield. They're for 165 miles thereabouts. They are saying it would cost $26 billion to complete it. That's even up for question. That would make it $156 million a mile. Air track has been costed out at $15 to $30 million a mile. And that's using all the basic, construction history of aviation, materials costs and weights. And air track for about $6 billion in 6 years could be in operation and outperform high-speed rail 3-to-1. Now, just take a look at the pictures here. This is high-speed rail in California, all three of these pictures, and it shows the massive comparison between their infrastructure and air track, and that's why the air track system costs so much less. The value of air track in Texas, Amtrak proposed 2.5 years ago to build high-speed rail from 6 miles outside of Houston to somewhere in the vicinity of Dallas-Fort Worth for $33 billion. I took a look at air track at $30 million a mile, our maximum number from Bayport to Houston to Dallas-Fort Worth and down to Laredo and back up to Sherman for $26.6 million. And again, will outperform high-speed rail. Wyoming has become very interested and are helping us to promote air track through State Senator Stephen Pappas. He saw this about 5 years ago, and his comment was the advantages of air track far outweigh any other mass transit option that he ever researched in the past 20 years for the state of Wyoming, their topography and their weather. Utah is facing the 2034 Olympics, and their light rail does not go up mountains. So they're getting interested in air track from the airport to Park City, right past the university. And that provides consistent, rapid, and frequent transportation for these upcoming venues. For a full brief, you can give James Pitchford a call or contact him on his email. You can contact me. We'd be happy to give you a full brief. And if you have any questions or questions, we'll try to answer them. Thank you for your time.
Thanks, Gene. I really appreciate that. The question I have for you is more general in nature. It seems like you've got a very innovative concept here, and it certainly solves a lot of the infrastructure investment requirements for like high-speed rail and the other options out there. There's a clear advantage in the numbers you've presented, but if you wanted to communicate one thing to our audience, what is it that you think you need to help get your message out and get more groundswell support for this type of mass transit that you've got patented and developed here?
Mitch, would you like to answer?
Sure. Jason, for the very reason that we wanted to participate in your gracious offer on this podcast, we need partners. We need composites companies that will ask for a brief from Gene, get a full brief. We're very transparent. We talk about all the attributes of the company, what it can do for this country. And the fact is, it will drive demand. That is why Zoltech wanted to partner with us. That's why they're promoting it. You've seen the potential for it. So has ACMA. We need partners. The more partners, composites companies that see the value to advocate with their officials, not for money, just for dialogue. We need to promote the dialogue in this country about alternatives to these high cost foreign competitors, right? All the competitors on high-speed rail, those are foreign companies. Gene's an American. This would be American designed, American built, for Americans. That was his reason. So we need partners. So we're hoping all the listeners here will ask for a brief. And when you look at this system, just try and imagine, you can't. There are going to be a lot of parts, composites companies involved in making this a reality. And we need as many partners as possible. So thanks for that question, Jason.
Yeah, no problem. Well, appreciate your time. Appreciate that presentation. We're coming to the end of the hour, so I'm going to go ahead and share my screen again, because I just want to remind everybody that we have some more upcoming Innovation Insights. Here's our current schedule. So you can see our next Innovation Insights will be Monday, August 17th. We'll do the standard 3 presentations. We've got a number of different key people signed up for that. And then in October 19th, we're doing another focused one, but this time it's going to be on infrastructure applications, specifically composites for data center construction and applications. So think about all the data centers that are being built at incredible rates, all the hyperscalers out there, and we're going to do a focused Innovation Insights around composites for those applications. So please join us for that. And with that, I'd just like to thank all of our presenters for their time, for their storyline, for the narrative that they presented. I think it was very compelling, and we appreciate that and appreciate the audience's time. So with that, I'm going to close this out, but thank you. Everybody have a great day.